Hi everyone. In my previous video, I implemented a RAG locally using DeepSeek R1 model where it can read from static PDF and give answers based on the PDF content. In today's video, we will do some modification on that and build a chatbot with an option to upload PDF. So the user can upload any PDF and they can ask questions based on the PDF. The chatbot will give answers based on the PDF content. Here is the demo of the chatbot that I built. We don't need any API keys for this purpose. This is completely local installation. By the end of this video, you will have your own chatbot that can read documents and give intelligence response. So how does this chatbot work? These are the steps that involved in this process. First, upload the PDF, then split the documents into chunks, then store the embeddings in FAISS vector database. Based on user queries, it retrieves relevant information and finally generate response using DeepSeek R1 model. Now we can set up the chatbot. First of all, we need to install DeepSeek R1 model in our local machine. To run DeepSeek R1 model on your local machine, we need a platform to run this model. For that, we need to install a platform called Ollama. First, download and install Ollama from the official website. Once Ollama installed, pull the DeepSeek R1 1.5b model by running this command: Ollama pull DeepSeek R1 1.5b. We are using DeepSeek R1 1.5b, which is a lightweight model. You can try with different versions of DeepSeek with various parameters. So now DeepSeek setup is completed and it is running state. Now we need to set up the chatbot using this model. For that, we need to install few dependencies. Open your terminal and run this command. This will install Streamlit for our UI, FAISS for fast searching, sentence transformers for embedding, and Ollama for using DeepSeek R1. I had already written the code and I will describe what are the major functions and how it works. Now let's start with reading a PDF. We use PyPDF loader from LangChain to extract the text. This function takes a PDF file and extracts its text. But raw text isn't enough. We need to split into smaller chunks so our AI can process it better. This ensures that the AI understands context while keeping chunks manageable. Next, we need to store our document in a way that allows fast searching. We do this using embeddings and FAISS vector database. FAISS is an open source vector database from Meta. This function, create vector store, is responsible for converting text data into numerical representation, which is embedding, and storing them in FAISS index for efficient similarity search. It do two things: generating text embedding using the sentence transformer model, storing these embeddings in FAISS index, which allows for fast retrieval for similar text when required. This is the core of our RAG pipeline. We transform our document into vector embeddings, store them in FAISS, and now we can quickly retrieve the most relevant chunks of text when a user asks a question. When the user asks a question, we don't search the entire document. We use FAISS to find the most relevant sections. This makes our chatbot much smarter. It doesn't just generate text randomly, it pulls accurate information from the uploaded PDF. Now we take the retrieved context and pass it to DeepSeek R1 using Ollama to generate human-like response. Here we set temperature equal to 0.3 and max tokens equal to 2000. Temperature controls randomness. Max tokens limits the response length to 2000 tokens. This ensures that the AI doesn't hallucinate. It only answers using the provided document. Now let's build the chatbot interface with Streamlit. We start with setting up the app and handling the file uploads. Once a user uploads a file, we process it and store everything in a session state so we can reuse it efficiently. Now our AI is ready to answer questions. We added text input for the user to ask questions and disable it while the AI is processing. Once the user clicks the Get Answer button, we retrieve the context and generate a response. To make the chatbot feel more interactive, we stimulate a typing effect so the answer appears gradually instead of all at once. Now instead of instantly dumping text, the answers appears as if it is being typed live. That's all about the code explanation. Here I am uploading a PDF that contains documentation about one of the services in GCP, which is Google PubSub. I will upload this PDF and ask what are the use cases of the PubSub. As you can see, it retrieved the data from the PDF. So using this chatbot, you can try with different PDFs and share your experience how it works. I will share the code and details in the description box. You can try it out and let me know your response. If you found this helpful, don't forget to like and subscribe the channel. Thank you for watching and see you in the next video. Bye.